Good afternoon, students.
Good afternoon, sir.
Good afternoon. So we were seeing about some of the introductory concepts of machine learning techniques. So in the second unit, we saw about the hypothesis. Then yesterday, at the last class, we saw about the inductive bias. So these topics seems to be a bit different in the sense that they do not completely blend with your machine learning, as we saw in the first unit. Right? Each one of these topics are independent, but some way they are related with each other. Right? So when you learn this, when you try to understand this, definitely the level of understanding you need is a bit high in comparison to the topics what we learned in the first chapter. So pay more attention to whatever I am saying. In addition, try to explore more on the websites. Some of the contents I have taken from many websites and merged together and giving you. But sometimes there may be some other contents also which may give you a better understanding of these topics. So in this line, today we'll be seeing the third content of the second chapter. Let me share my screen. Is my screen visible?
Yes, sir.
Okay. In full screen mode?
Yes, sir.
Okay. So today we are going to see the third concept related with machine learning, which is called as underfitting and overfitting. Right? Normally, whenever we go to purchase or buy a shirt or something, dresses, right, we always go to the trial room, right? Without trial room, we hesitate to buy that specific product. If it is online purchase, then it's different. But normally, when we go to any textile shops, all of them have the trial rooms also. Right? So we check whether the fit is exactly matched with our body structure. Maybe they may say 40, but it may not be exactly fitting us. So we change that and try to make sure that the fit is exact. Right? If the fit is not exact, sometimes the size may be too less in the sense that it may be very tight for you, right? That is called as underfitting, right? Normally, generally. And that sometimes you may get a size, a bigger size, right? So that is called as overfitting. Right? So this is normally used words in the general situation when we go for a dress or something like that. The same thing is applicable for our machine learning also. So remember, these two words are drawbacks for any machine learning model. When you feel that your machine learning model is not giving that much accuracy when you go for performance evaluation, maybe one reason may be underfitting or one reason may be overfitting. So in this session, we will be seeing about how underfitting and overfitting affects the accuracy of any machine learning model. So this line is general. You know that a model is said to be a good machine learning model if it generalizes. So last session we saw about the generalization concept. So I kindly request you to go through the PPTs also, because the words or the sentences which I'm using in this session will be the previous session's explanation. Right? So it will be better if you can have a prior understanding on this also. So if it generalizes any new input data from the problem domain in a proper way, try to find a perfect relation between your input and target. This helps us to make, once it is trained, right? Once it is learned or trained with that specific data, then it can take a decision on a data which has never seen, which we call it as a training process and a testing process, right? Which we saw in the first unit. We have a training process and a learner and a reasoner. So this helps us to make predictions in the future data that model has never seen. If your learning process is perfect, then 95 percentage or 99 percentage, your testing process also will be perfect. This is what we are looking at. Right? But sometimes in this training and testing, there is some mismatch or some drawbacks available, which is ensuring that you do not get a proper accuracy in the final output of any application. That is all about your underfitting and overfitting. There are two reasons, right? There are humpty number of reasons may be there, but the two major reasons which causes the learning model to generalize inaccurately. Generalization is there. I'm not saying generalization is not there. You are able to find a relationship, but that relationship between the inputs and targets are not accurate. That means you are unable to gather the information from the data, so that when new data is given to you, you are unable to take a decision in classification, regression, association, or trust. So these reasons are called as underfitting and overfitting. So first we will see about underfitting, and then we will see about overfitting. What is underfitting and how it affects your machine learning model, and what are the techniques you can have to avoid this underfitting. So what is this underfitting? Right? Your shirt or your pant or your dress, whatever it may be, is very tight. Right? It is very tight. When it will be very tight, then the material is, the raw material is very less. Right? The raw material is very less. In other sense, when we correlate it with your machine learning algorithm, when you supply an insufficient data to ML, then there is a high chance that your machine learning model will suffer from this underfitting. Is said to have underfitting problem when it cannot capture the underlying trend of the data. When I say underlying trend, the significant feature of the data. Say, for example, we want to differentiate two persons' face. Say, for example, person A and person B. So now, when you take some features from these two images, those features should be specific for person A and person B. So that specific characteristic features, I'm going to call it as underlying trend, an attractive one. Right? How I can differentiate person A and B. But what happens when I say underfitting? I am unable to capture the specific characteristic features of A and B. It is just like trying to fit undersized pants, right? It will never enter your legs, or if it is a shirt, it will not be possible for you. It indicates sufficient information necessary for generalization is not captured, right? Sufficient information necessary for generalization is not captured from the training data. Or if I say the sentence in another way, I can say insufficient data. Insufficient data. If you want to do face recognition, you cannot just test with one image or two image and say that my method is working in the best possible way. That is false. Because with one image, I will not be, or the machine learning model will not be able to capture the complete information of that specific person. Right? The angle in which he turns, the lighting conditions, maybe the different orientation of the faces, everything is necessary. So when you supply with less amount of data, there is a high chance that you will not get a better accuracy for your machine learning. So the concept of underfitting is less amount of data, and your system or your machine learning model is not able to capture all the specific characteristic features of that data. That is very, very important. Only if it captures the specific characteristic features, it can give it to the system for classification or any other application. It usually happens when this situation happens when we have less data to build, when you supply the model with the less amount of data, right? Say, for example, COVID-19 detection. We have developed a model, a machine learning model with the help of for COVID-19 detection, in the sense that how to differentiate pneumonia and a person affected with COVID-19 with the help of lung images. But the problem we face is COVID-19 is a very new disease, right? In that case, the availability of raw materials or the availability of database will be a big question mark, right? If it is tumor or cancer or whatever it may be, then you can have plenty of images, maybe for the past 20 years or 30 years. Online database are available. You can go to the hospitals where you can collect the data. But when you go talk about COVID-19, the amount of data will be relatively less. But can we go for a model still with that less amount of data? The answer is yes, you can go, but you cannot guarantee a good accuracy. So you will face some application where you will find this type of data very, very less. And also when we try to build a linear model with a non-linear data, right? For this, you must understand the concept of linear and non-linear. What is linear? The pattern will be same. Say, for example, 2. When you give an input data of 2, you will get an output of 3. Right? When you get an input of 3, it will be 4. That means when your input increases by 1, your output also increases by 1. So when you draw a line or a graph between this x input and output, x-axis and y-axis, you will get some a slant straight line, right? Maybe in a different angle depending upon your value, but it will be a straight line. So now you are expecting to have a linear model, right? Output to be a straight line or something like that, but your data is non-linear in the sense that for 2, you are getting 3. When I go for 3 as input, I'm getting 100. Then when I go for 4, again it is dropping down, maybe 50 or 60. So when you have this chaotic set of data, you can build a non-linear model. But when you try to go for a linear model, right, then you will face this type of problem of underfit. That means your accuracy will not be very good. Right? But you can feel that these machine learning models are too easy and flexible to be applied. Right? Why? The data is very small. You have only one image, right? 256 cross 256 pixels maybe, or any 30 cross 50 pixels, or any, if it's a signal, only 30 instance or 550 instance, you will have the value. So when you give that such a value to the system, the time taken for the training process is very less, right? And the memory storage is very less. So we can generalize that it is easy and flexible when we go for dealing an application with less amount of data. Right? Even if I give you 1 page of content to learn or to study, I say that for your second internal exams, you just read this only one PPT. That is enough. It will be very easy for you. But what will happen? If I ask some other question in the exam, right, you are going to make only a wrong answer, right? That means your model will probably make a lot of wrong predictions. Less data, the process looks easy, but when you go for your output, the accuracy will be very, very low. So how can we reduce this concept of underfitting? Increase the amount of data. Very simple. That's why whenever you go for machine learning or deep learning based projects, whether it may be mini project or major project or research work or anything, the first thing is how much amount of data you have plays a major role. That's why I told you in the first class, machine learning depends upon the past history of data. But how much amount of data? Right? The more, the better. Increase the model complexity, right? Because you have very less amount of data, it will be an automatic temptation for the programmer or the user to have the simplest model, because the data is less. Why should I go for a complex one? But when you go for complex one, the system or the model will try to capture the significant characteristic features even with that single image or single data. Increase the number of features. As I told you, if I want to differentiate A and B, just taking 2 or 3 features may not be sufficient. If I go for taking more number of features, then there is a chance that my accuracy may be high. Right? It can be done with the help of feature engineering, which we saw earlier. Remove noise from the data. Right? Sometimes, even with, say, for example, COVID-19 lung images, it may have a differentiating characteristic feature from the pneumonia images. But sometimes there will be other ribs. And when you take the image of a lung, you will have the ribs and all other tissues will be there. That may be hindering some effects in that specific image. So when you remove that, which we feel as noise, it's not exactly a noise. Anything unwanted for us can be treated as a noise. So when you remove that, the chances of taking the accurate information or specific information from the image data may be increased. And increase the time of training, right, to get better results. It will be a normal thing for training the model for less amount of iterations when you have less data. We think that we have studied, we learned within one PPT or two PPTs. When it is applied to you, you will take very less time for learning. That may be fine. But when you learn for more time the same data, there may be some different angle information that you may get. Right? Why we go for this or why we go for that? That idea you make it, which may help you to go for the correct answer in your exams. Right? So it's a normal tendency. One PowerPoint slide, we will go for finishing it very quickly. But if you learn more, each and every word, if you analyze, you may get n number of ideas. That's what machine learning models also does. They look for increasing the number of epochs. Epochs means iteration. Technically, we call it as epochs. Right? How many iterations we go for? Iteration means one step. Every algorithm will have a first step or a starting step and an ending step. So when you go from one to last, it is called as one iteration. Again, you will come back because you know that all supervised models have error. So to reduce the error, we repeat the same process again, and again with some change in the values. So that we call as iteration. So if you increase the duration of training, we may get some better results. Now we will go into the concept of overfitting. So overfitting, supplying with huge amount of data. This statement may be contradictory to you. So when I talked about underfitting, what I told you, supply with more amount of data. Right? But now when you supply with huge amount of data, then again there is a chance of overfitting. Right? In Bible, in Tamil, there is a beautiful verse there. Right? Adiga padipu udalukku. Can anyone complete this sentence? Adiga padipu udalukku. Anyone? No Tamilians there? Okay. Adiga padipu udalukku ilaipu. It's not good for the body. Right? Maybe I do not know in the English version of that. Right? But the thing is, when we supply more amount of data, your machine learning model may make mistakes. Now that will be a big question mark, right? It may not be possible. You may think it may not be possible. When we are given with more contents, definitely it should learn well and give a good output. But what make it give a very weak output, even when I supply with a large amount of data? This overfitting is just like fitting ourselves in oversized pants. So when the model gets trained with so much of data, right, it starts learning from the noise also. So what is noise? Noise is anything which is not necessary for you can be called as a noise. Say, for example, there are three dogs sitting in a park, right? So when you look at a park, you will have trees, you will have people moving here and there, you will have the image of plants or shrubs will be there, small children will be playing, there will be balls, everything will be there. Now your idea is your machine learning model should tell whether that image has a dog or not. Right? Now you are giving the image directly to them without telling the machine learning model which one is important. So now the machine learning starts to learn, and because it doesn't know which is important, it learns everything. It learns ball, it learns tree, it learns the pond, the people, the sky, the clouds, the crows, and everything it will learn. The dog also it will learn, right? Because it has learned everything, when I go for testing it with some image, then it will be having some confusion whether if there is any other feature which is close to dog, then it may make some mistake, right? Then it may make some mistake. So it is just like learning more. When we learn more, there's a high chance that we will learn some unwanted information also, right? Learning is all about learning only the necessary thing. But the generally when we say learn this, study this, it's like a general word. You learn everything and you study everything. Then there is a chance that you will learn something unwanted, which may again cause a damage to the accuracy of your overall system. And the second one is inaccurate data entries. Right? Just face recognition of human beings. You cannot have a face of a dog or an elephant there. Right? Face recognition is a general word. But internally, I'm talking about face recognition of human beings. You cannot have a face of a dog or a cow or something like that, which will again cause problem for the system. Just because you think that we need to supply with more amount of data, you cannot go for inaccurate data entries. Right? So these are the two reasons when your system is supplied with more amount of data, the chances of accuracy may getting a good accuracy may come down. So the idea is don't go for very less amount of data. Don't go for extremely more amount of data. You need to strike a balance. Your fit should be perfect, like shirt, right? When we go for it should not be tight and at the same time it should not be loose. Exactly the same thing is followed in our machine learning model also. So if that is the case, it will not be able to categorize correctly because of too many information, and too much noise. And these causes of overfitting are mostly seen in the non-parametric and non-linear methods. Right? Because when you go for non-linear methods, there is no pattern, there is no standard pattern. So whichever way you want to go for, you can go. So you have more freedom in building the model. You may think that I let me go in this way, and all those things. But when finally, when you go for coming for to the testing process, when you come to the testing process, finally, you will face the difficulty. You have flexibility in designing to that during the training process. You will learn everything, right? But when you go for testing, you will face the problem. So the idea is in underfitting, the training itself is a problem because a less amount of data. But in overfitting, training you learn everything. But only when you come for testing, you will know whether you have learned a noisy data or a correct data. So it depends. So how can we avoid overfitting? If we have linear data or using the parameters like, say for example, if you go for a decision tree based algorithm, we have a concept called as maximal depth. If we set the parameters correctly, or if we have linear data, then we can avoid overfitting to some extent, or we can reduce the amount of data also if you want to go for overfit, if you want to avoid overfit. So the first two examples are for underfitting, right? Underfitting. So you can see clearly that your line, right? Your line will not all cross mark should closely follow the line, right? Should closely follow the line. But some cross all are same data, right? They do not have any different shapes. If they have different shapes, then one may be on the upper side and one may be on the lower side, no problem. But here what happens is all the data of same category, the same shapes, some are on the upper side and some are on the lower side. Again, it will cause a damage to an accuracy, right? Even if it is a curved one, right? Not exactly linear, maybe a bit more function with non-linear. Again, you can see the same problem, right? Now it is a better one. When you compare with a straight line, the cross mark is very far away from the line. But when you compare this second one, it is closely following the red curve, the training process, but still two cross are on the lower side and three cross are on the upper side. And overfitting, it is going to be completely non-linear. You will going to build a model depends upon your necessary. So what happens? Your red line exactly matches with your cross mark. Your training is good. Your training is good. But in the underfitting process, the first two diagrams, your training itself is bad, right? But even though you have a good training in your overfitting or the non-linear model, what happens in the testing process is very, very important. In testing process, we fail because we learned everything. So when we get a new data, we will not be able to find out whether this is this or this is this, because so many confusions are there in the human brain or machine learning model. Again, an example for underfitting, zero circles, it is spread across your data, right? But when you look at the appropriate fitting, now you can see that all the circles are on one side and all the most of the cross marks on the other side. But when you look at the first diagram, circles are in the cross side, crosses are in the circle side, right? Which will cause more damage to the accuracy. But when you go for appropriate fitting, only two cross marks. You cannot get 100% result every time, right? Two cross marks are there, but that is fine. Look at the third graph, which is an overfitting, right? Perfect one. Perfect one. But is it realistic? Is it realistic? Can you draw a plot, a graph like this? Very, very difficult, right? All zero come under one category. The third one, look at the third graph, all cross come under one category. But training wise, it is okay. Learning wise, okay, you have got a lot of information. But in the testing process, definitely you will have a confusion. So how you can reduce overfitting? You increase training data. At the same time, you make sure that it should not be too much. It should not be too much. When I say techniques to reduce overfitting, I'm comparing it with underfitting and giving these points. Right? So your training data should be almost somewhere in between your lower level and the maximum. Reduce model complexity, and that doesn't mean that you have to come to the level of underfitting. Somewhere a balance should be given. Right? And early stopping in the sense the training time I told to increase when you go for underfitting. Now, when you go for overfitting, just stop somewhere a bit earlier. Right? That doesn't mean you need to go into the category of underfitting. So you need to have a very, very good model in the sense that even a small shift towards the positive side or a negative side may cause you either underfitting or overfitting. So this is a good fit. How we can have a good fit, right? Ideally, the case when the model makes a predictions with zero error, right? That's an ideal case, which is not at all possible. But if you look at this graph, the second one, the appropriate fitting, you can see that all zeros are perfect. All zeros are perfect. Only the cross mark, two of the cross marks are misplaced. This may give you some accuracy around 98 or 97%, depending upon the number of crosses and circles. That is fine. But if it is exactly zero, then we call it as a good fit on the data, right? So this situation, as I told you, is a spot between overfitting and underfitting, which is very, very difficult to understand when you go for a machine learning model. Right? Only after getting the results, you will realize, okay, I would have improved some data, make some changes to remove this underfitting and overfitting. So once you get an evaluation, you will know how your model is behaving. If your model is behaving wrongly because of the large amount of data, then you can remove some amount of data, and then again you can execute the same thing. Right? Or if you feel the data is very less, you increase the data and less. So depending upon the result, right? Initially you will not be able to identify. Only if you evaluate your system and check the error, and based on the error, you can come to a conclusion whether it is low or high. Again, if it will learn for too long, the model will become prone to overfitting due to the presence of noise. But if it is too less, again, the chances of underfitting is there. So you need to stop at a specific point, which is somewhere perfect in between underfitting and overfitting. So if you ask me, sir, is there any possibility that I can get 100% accuracy for my model? No. That means good fit is not at all possible. But how much you can avoid? Can we get 98%, 99% accuracy? Then it is fine. That depends upon the data also. For some data, signals or images, we will get a good amount of accuracy. For some applications, the accuracy is always only in the range of 86, 87%. At that time, you should not go and change the underfitting and overfitting. That is not at all possible. You cannot change that. So only by practice, you can look at the data and all these points and come to it. So I will give a small example for you. Let us say that 3 students have prepared for a mathematics examination. Right? Take 3 of you, right? 3 students from your class. The first student has studied only addition. Right? He has studied only addition operation and skipped subtraction, division, and multiplication. It's a maths exam. It's not an addition exam. It's a mathematics exam, but he has learned only addition. There is another student, second student. He has a particularly good memory. So the second student has memorized all the problems presented in the textbook. Right? The data is given, so he is not bothering about whether it is addition, how many marks are, all those things. He is giving a full go at the textbook, and completely he is learned. And the third student, right, has studied all mathematical operations. So now you have to understand the difference between the second and the third. I told The mathematic operations are important: addition, subtraction, division, multiplication. So the third student know which one he need to give more concentration on, which one is important. The second student also know that, but he do not know that which one is important. So he studied everything in the textbook. So now we will see how these are the training process. These three are trained. Now they are trained with that specific skill. Now when they go for testing, when they face their exam, what happens we will see. In the exam or the testing process, the student number one, right, this first student will only be able to solve the questions related to addition, right? You will agree because he has learned only addition and will fail in problems asked related to other mathematic operations. That means he comes under the category of underfitting. Right? Only one face image I have shown to the machine learning model. When I show same person's image but with a different orientation, it will not be able to recognize. This comes under the category of underfitting. Student 2, right? Student 2, what is the problem of student 2? You may think that the student 2 will answer all the questions because he has studied the complete textbook, but the answer is no. Student 2 will be able to answer questions if they appear in the textbook, right? As he has gone through the complete problems only in the textbook. Maybe you can have a differentiation between memorizing and understanding. That is up to you, right? He has gone through all the problems in the textbook, and if I ask any problem from the textbook, he will be able to answer, right? But real-time machine learning model, the testing data or unseen data may be from different varieties. You read newspaper, they say talk about the second variant of COVID-19. It will not look like the same one. Which if I have a machine learning model with the trained for the COVID-19 first version, this will not be. This will be slightly different. Not exactly different, slightly different. But still, my machine learning model should be able to give the correct answer. But if it behaves like student 2, it will not be able to do that. Student 3 will be able to solve all the exam reasonably well because he know which is important and which is not important, and he gave importance to addition, subtraction, multiplication, and division. That is the best possible way. First one is underfitting. Student number 2 is overfitting. Student number 3 is the proper fit, right? Exact fit. But do you know? Do you know whether all these things are important? So good fit is not practically possible because most of you, if I ask you, you may come under category number 1 or category number 2. I am not sure how many of you will come under category number 3. If you are in 3, then I will be very happy. So as I told you, underfitting. Then the second one is overfitting. You must understand why that case is underfitting and why this case is overfitting. Only then you will be able to try to develop some solutions, or you, even in your project, you will be able to find out what may be the problem for your poor accuracy or your inferior accuracy. And the third one is the good fit. And this is a simple diagrammatic representation. So whenever we have a model, if it performs well on test set, right? Training. If it is performing well on test set, the training is also good, right? If both are yes, then it is a good model. But if you feel that it is not performing well on test set, no. Then again there is a two option, whether it has already trained well or whether it has not been trained well. So if it is trained well, right? If it is trained well, but it is not able to do well in the testing process, then we call it as overfitting. Training wise, everything is perfect. Training graph, as I showed you, the graph, everything will merge and it will be perfect. But when it is given a new data, it struggles. Like a student memorizing the contents, it struggles. Right? When you go for underfitting, what happens? Training sariyilla, testing sorry. Training is also not proper. He has not learned anything, and automatically what happens? He will not be able to perform well in the testing process. Right? So underfitting, it should be completely avoided in any machine learning model. But overfitting is a bit a tricky issue. Like in the deep learning models, we have several researchers and scientists are developing many mathematical add-ons to the models to make sure they do not suffer from overfitting. But if you say that I have an underfitting problem, no, you are wrong. But if it is overfitting, maybe you need to do some tweaks here and there to make sure your system is. I hope you got a complete understanding of what is underfitting. And any doubts, students? If you have any doubts, don't hesitate. You can ask me then and there. Let me mark attendance. But when you go for a normal project with your machine learning model, nobody will talk about underfitting, overfitting, and you will get some program, you will get some result, and that is fine, right? These are deeper concepts. If you want to become actually a machine learning engineer, then you need to go into, you must know all these concepts. Later, we do not know. When you get placed in Amazon or IBM or any other good companies working with deep learning or machine learning, you may need all these concepts. At that time, you will realize the necessity of these concepts. Let me mark the attendance. Amulya. Amulya absent. Judson absent. Samyukta.
Present, sir.
Angel.
Present, sir.
Ajit Pawan. Chat box. Abhinaya.
Yes, sir.
Kiran Kumar. Okay. Kiran Kumar absent. Manideep.
Present, sir.
Banu Teja.
Present, sir.
Jennifer. Absent. Priyadarshini. Jeevan.
Present, sir.
Afreed.
Present, sir.
Jayant. Okay. Vikas.
Brian, sir.
Valsani. Bhuvaneshwar.
Present, sir.
Sumant Kumar.
Present, sir.
Ramesh Kumar.
Present, sir.
Neeraj Kumar. Okay. Zubair.
Present, sir.
Kirti. Okay. Dinesh.
Present, sir.
Tejaswant. Chandana Priya.
Present, sir.
Karthik.
Yes, sir.
Vijay Kumar.
Yes, sir.
Soman.
Yes, sir.
Janish absent. Vimal.
Yes, sir.
Rex Vimal
Yes, sir.
absent. Harshavardhan.
Yes, sir.
Uday not there.
Chat box, sir.
Okay. Sakib.
Present, sir.
Krishnan.
Yes, sir.
Praneeth.
Yes, sir.
Salomi.
Yes, sir.
Libinson.
Yes, sir.
Alan.
Yes, sir.
Ronan. Sai Kiran.
Yes, sir.
Yoshiba.
Yes, sir.
Shiny.
Yes, sir.
Jasmine. Okay. Celestine.
Yes, sir.
Kavya.
Yes,
Jay Surya.
Yes, sir.
Jona Paul.
Yes, sir.
Manasa.
Yes, sir.
Ashrita.
Yes, sir.
Narasimha Reddy.
Yes, sir. Yes, sir.
Puneet Kumar. Shiny. Shiny Rebecca. Okay. Joshua Victor. Nagakiran.
Yes, sir.
Suraj.
Yes, sir.
Suraj. Maunika.
Yes, sir.
Maunika. Okay.
Yes, sir.
Taufik.
Yes, sir.
Manideep.
Present, sir.
Dikshit.
Yes, sir.
Maria Angel. Angel. Amrut.
Yes, sir.
Pavan Kalyan.
Yes, sir.
Sainath.
Sir.
Gautam.
Yes, sir.
Jagat Chandra.
Present, sir.
Vivekananda. Vivekananda. Vivekananda absent. Shashank.
Yes, sir.
Sai Ganesh. Sai Ganesh. Okay. Gopi Chand.
Present, sir.
Ritvik. Ritvik.
Yes, sir. Yes, sir.
Salaman Raj. Salaman Raj absent. Sudarshan. Sudarshan. Okay. Sujit Kumar.
Present, sir.
Suresh Kumar. Suresh Kumar absent. Sunny.
Chat box.
Present, sir.
Suresh. Okay. Suresh Kumar is there.
So this is 144.
Sunny. Sunny is there.
Yes, sir. Present.
Amrita Das.
Present, sir.
Okay. See, don't bunk the classes because the each word which I'm going to utter in today's class will have a detailed explanation on the previous class. I am not sure how you can follow the contents if the flow is missed. So please, if maximum possible, try to attend all the class. I'll read out the absentees. Number 5, number 7,
Sir, 7%, sir.
7%. Number 6, number 9, number 40,
So 41.
41,
So I gave in chat
54.
box.
You
Yes.
gave in chat box.
Yes, sir.
Rex Vimala. 54, 124, and 133.
Sir, 132 present, sir.
132 I have marked. No issues.
Okay, sir.
Ritvik I have marked. Okay, if you don't have any issues, you can leave the Google Meet.